Hi guys, my name is Anton. It's an honor to be here representing our company, our team. Our company is Everymundo. Before I start this talk, I wanted to see a show of hands. Is anyone here in the travel space or deals with pricing distribution? Okay. Perfect. Okay. So we're going to talk about how we use Spark to distribute pricing for our customers, in this case, the airlines. Before I start, I want to leave you with a quick summary. I'm going to tell you a little bit about who we are and what we do. I'm going to introduce to you our data ecosystem, and then Daniel, who is our lead developer on big data, is going to walk you through two specific examples of how we use Spark. Okay? So let's get started. Our company is Everymundo. We're based in Miami, Florida. We've been around for 10 years, 6 years working only with airlines, and currently we count 23 great airlines as customers. And in honor of June being Immigrant Heritage Month, I wanted to show you guys our team. We are immigrants. There's 57 of us. We call ourselves Mundos. 65% of us are born outside of the United States, 11 different nationalities. So this is a little fun fact here. Okay? We're all here for the American dream. Our why. We exist to transform how companies innovate through our technology and knowledge. And specifically with airlines, we transform how airlines communicate with their customers in real time, online. And we use Spark. I'm going to go through some examples of what we do and how we leverage the pricing distribution that we collect from all of our customers, so you can see it working in real time. Just like Amazon has a page for every product they offer. That page shows prices, reviews, most popular products, etc. We believe that airlines should have a page for every flight they offer. It's their product. Here's an example of one of our customers, and let's break it up. Here's how you search for a flight. Here's a title of a particular flight from Miami to Berlin with a price that is populated in real time. A histogram with appealing pricing, right? And a calendar with also pricing. Another example, Ryanair, flights to the Greek islands, many different prices displayed, different currencies, right? I'll walk you through a bunch of them just so you understand. In search, somebody searches for flights to Berlin. We know that they're in Miami, and we give them the most relevant price for a flight to Berlin. All of that is being done leveraging Spark. Same thing as in display. Somebody's reading an article on the Greek islands. We should deliver to them a price displaying that a reasonable flight. On social media, we try to learn from our customers. We know somebody lives in Miami, Florida, and they like Machu Picchu in Peru. So why don't we display an ad for flights from Miami to Peru, and then continue that experience with pricing in local currency from Miami to showcasing the same flight that they see from Miami to Peru. We continue with email. An airline sends an email. That price is displayed in the email. We know that it's flights from Denver for $34. We send them to a page that has all these pricing output and highlighting the flights from Denver for $34, continuing the experience all the way through. We also allow our customers to interact with the pricing and with the data to understand what are the most popular flights, what are the most popular prices, what the currencies, locating it to their origins, right? So you can change the price filter, a date filter, or a location filter. And we don't only have to do this in English, we also have to speak their languages and their currencies, right? So we have to output it in multiple languages. We're now working with chatbots in order to interact with the consumer on the go and be able to talk to the consumer and output prices and have the consumer book a flight from their mobile. In order for this all to be a reality, and it's actually, obviously our customers are using it today, and millions of people are seeing them, we had a lot of challenges, and I want to go through them so that, to put you guys a little bit in our shoes. We deal with very large data volumes. We collect every single interaction that a consumer has with an airline's website, their prices, the popularity, et cetera, different currencies, different markets all over the world. Many concurrent requests. The airline space is a very unique space because prices are very volatile. Not only is it based on availability, right, of a particular seat, but also volatile currencies, right? A price right now in the US for $100 is not the same price as it is in Brazil, where Daniel's from, because their currency fluctuates, right? We also deal with a lot of United States Department of Transportation and international pricing regulations, where you cannot advertise a price that is out of date. Therefore, we need to output the prices as we see them in real time, or as close to real time as possible. And last but not least, the markets, the different markets, the different languages. How do we communicate to the consumer these fares, this popularity, et cetera? So in 2016, we set out to build what we call DataCore. That's our big data processing platform. And that poster that you see up there is the handwriting, is what Daniel and I actually wrote on a big note that still stands at our office. And DataCore's purpose was to output revenue impacting products. Its core values were accuracy and accessibility. We needed to centralize data, quickly integrate new data, update large data structures, smart data aggregation, churn data, high accessibility of data, real-time performance, interchangeable parts, very important, and very clear data structures. So today, DataCore is live, empowering all the experiences that you just saw, and we built it leveraging Spark streaming and batch processing. As I mentioned, it powers every single one of our products, and the most important thing that it does is it gives access to our data to everyone in our company. Those 57 Mundos that you saw in a picture, they all have access to our data in order to be able to visualize products and visualize experiences for our customers, the airlines, and their customers. Here's a quick, our company blueprint and DataCore. Here's DataCore sitting at the center of it, right? Data comes into DataCore. Data gets outputted in Redshift and BigQuery. Our company accesses that data. Our company creates products, and DataCore powers all of our products in the different categories that we play, which is traffic acquisition, customer acquisition, infrastructure, and conversion, right, of actual sale of a ticket, okay? Here's a quick video of the data flowing through DataCore, leveraging Apache Spark, sorry, in real time. Well, it was in real time when the video was taken. But this is how we can monitor how the data is flowing through. Now, before Daniel gets up here and goes into some of the details, I wanted to give you the two examples that we're going to discuss and put your mindset on it, and then Daniel will go in with how we evolved and how we use Spark. So Spark is being leveraged in DataCore, and one of our products is called the Air Index. Air Index is a proprietary index that essentially tells our customers, the airlines, what routes they should be marketing right now or in the future, right? So we calculate our index based on real-time demand, and we're also predicting the demand curve, and real-time pricing distribution, again, also as well predicting the pricing. Once again, pricing for an airline is extremely tricky because it varies by time, by proximity to the departure date of a flight. There's multiple departure dates. There's different seats. There's different availability. So we have to take that all into account in the distribution of, as we calculate the probability of the distributions of pricing in order to tell the airline when to market a route now and in the future. The other example that Daniel will talk about is RDPI, which is how do we get prices in real time, dynamically inserted into all of our ads, right? We collect these fares in real time across different currencies and different markets, different classes, different dates. And we have to output and calculate constantly what is the best fare seen in the next 90 days. Then once we actually output that price, which is in the ad here, that price needs to match the current price displayed on the airline's website, right? So how do we coordinate all that? And obviously we have to do it localized to the customer, right? The currency takes is another big part of what makes this a little bit of a complicated problem. Okay, so now without further ado, here's Daniel Santana. He will talk to you guys about how we leverage Spark with RDPI and our index. Thank you.
Hi, everyone. Can everybody hear me? Okay. So I am the lead developer, leader engineer, leader data scientist, leader whatever for this project here. We had a problem at the beginning of last year. We needed to create an application that has this real-time dynamic price insertion. So the ads he showed here are ads that we manage, right? And the prices that we show in the ads, they're really changing dynamic real time. So the airlines, they don't need to think about it. When their price change, most of them don't even know the price is changing. And in a matter of a second, the price is already changing, all the ads, all the different languages, different markets, different currencies. And that's the biggest value of this product here. The challenge was the thousands of records per second that we had. And the output is not the same rate as the input, right? So we don't publish everything we get. There's some rules. So we have to analyze in real time per route and per currency. For example, from Miami to San Francisco in US dollars for the next 90 days of departure. So we need a state for that. And that analysis has to run 24/7. Those ads, we thought first we needed milliseconds, but we actually didn't need milliseconds. So we need to have them updated as quick as possible, but always in a few seconds updates. What to do? At first we thought that we could just, create a reactive application. You receive like a post, a webhook, and then you publish. But then that would not be enough because we would have to be querying databases to check the state, and that would be very slow based on the volume that we have. Then I said, I got it, man. I got it. So we need a fast streaming app. Voila, right? Everybody knows that. So we thought about starting from scratch. with this previous solution that I told you guys. It was perfectly possible, but we also thought we could just do some research. We didn't have any big data solution. We didn't have any a deep knowledge about this market. So we were very new to the big data scene at that time, 1.5 years ago, right? And then we thought, okay, let's start from scratch. Will it be easy? Nope. Worth it? Absolutely. Absolutely not, right? It's a lot of effort. Like we saw, no, let's just, think a little bit further. No, let's not do that. So when we started researching about the options and our reality, we saw, I don't know, maybe like half a dozen, 8, almost 10 options, and those were the 4 options that actually was shiny at the time, right? All of those options. Spark Streaming, Storm, Google Cloud Data Flow, or Apache Flink. Does anybody here use one of the other options here? One person, great. And does anybody here use Spark? That's awesome. Who is here evaluating if you guys are going to use the Spark or not? Great. So I hope I can help you guys, because we had this doubt, right? Like we had this doubt at the time. We started evaluating Storm, Apache Storm, and the pros were like support many languages. We have a lot of developers, and everybody knows like at least like 4 or 5 different languages, and somebody is better at one language, the other person's better at the other one. Okay, so Storm was going to be a good option, but based on our needs for keeping the state, it was a little complex to develop and to maintain. And then Apache Flink was brand new at the time. Some people were talking about it. It was meant for streaming. They were seeing this scene coming. They knew the streaming was very important. It was really fast, but the cons was it was only Java API. So we would like to leverage more developers, and the community was small at the time. Then Google Data Flow. I really thought that would be the solution for us, because Google Data Flow, the Cloud Data Flow, that is the service that they provide, they actually open source that as Apache Beam, if I'm not mistaken. And it's a platform in which you can work with multiple frameworks. So you can work with Apache Spark, you can work with Apache Flink. So why not use that, right? And if I change my mind, I'm not stuck to one solution. But the problem was that Spark is an open source framework that is developing really fast, really quickly. I don't know if you guys follow the blogs and all the features that they are planning, but there's always news, always exciting news. So in order to keep up with those new features that they were launching, Google Cloud Data Flow would have to adapt their code in the same pace. And you guys know that never happens, right? Like you have to wait. So everybody would be using the cool features, and I would be there like, like I want to use it, but I can't. So then we saw Apache Spark. The pros: multi-language, large community, and the cons, we didn't find any. We noticed a fast development cycle, and those 2 little names, EMR and Databricks, they speak volume, right? Like they speak for themselves. It were only pros. Some people, they were saying, oh, but it's not real time, it's micro batching. Whatever, man, it works. It's beautiful, it is fast. We have like one single API. It's easy to teach, it's easy to learn. And so there was actually no cons for us. So, and the winner is? Starting from scratch. No, I'm kidding. The winner is Spark, right? We were very excited, and okay, let's get Spark, let's start everything. And the RDPI, Dynamic Price Insertion, that was our first deployment. We had Spark 1.5 written in Python, and to keep the state, we had this feature, the update state by key. I know this is a business talk, I don't want to get very technical, but that's a function or a feature of Spark that you can keep data in memory. And for the streaming, when you're receiving data, that data goes through a state of the key that you create, right? Like you're receiving many records, you have to identify that record and put that record in a group that is identified by a key or an ID. And that function is going to run through all that data that comes. And it was pretty cool. We developed really quickly, and it's Python. Everybody knows Python. You need to know like very deeply, and it was really cool. We got it, and as soon as we had the first version ready to go to production, we deployed it with EMR. They launched it 1.6. We're like, oh man, I'm gonna have to like rewrite all the code and everything, but it's cool. Let's try. We just updated and it was working, like the same version. So that was the first moment in which we thought we made the right choice, getting Spark, because there was no problems. It was actually more stable. I don't know, has anybody here used EMR, AWS? 1.5 years ago with the Spark, it was not like the best option, but we are all our solutions are based on AWS, so for us it was really quick, that option. And with 1.6, we noticed that out of the box, it was more stable. And imagine you guys are working, right? And you have your boss paying you, and then somebody else, like the Databricks and all the committers, they improve the version of the software, you update, you didn't do anything, and your software now is better. Like, and everybody, oh man, you're great. Like, that was amazing. It was a great option, choosing Spark. So with the 1.6, they actually created a new feature for state called Map with State. And it was kind of like revolutionary for people that were using streaming with state, because it changes the way it works for the data that is coming in. The previous one, the update state by key, every time you receive data, it goes through all your state. Imagine, in our case, we had prices for, let's say, 1 million prices in memory, like just like when you first start running the application. And for each price, each combination, you have 90 days of data in the future. And if you receive one price, that update state by key is going to iterate over all of the 1 million. You know, so it gets kind of slow as your state is growing, as your keys are growing. So the map with a state would be amazing. And I started reading the documentation. Man, I want to apply this thing, but it doesn't work with Python. And I was like, man, I made the wrong choice, man. I should have like taken Storm or something different. And so what are my options? Right? Well, what were our options? We stick with Python and stick with update state by key, or should we move to the map with state? So 1 or 2, if you guys had this problem, which one would you pick? 2. But then I would have to learn Java or Scala. I mean, I knew Java. I didn't know Scala at all. I thought, okay, let's do it in Java. Let's write like 10 times more code to get the same feature. And then I look at Scala. And I'm like, why are they writing this thing in Scala? Let's look at it. And when I look at it, I was kind of fell in love with it. Man, this is beautiful. I'm going to learn this. So in 2 days, we converted our software from Python to Scala, and we were using the new feature, and we deployed. And I couldn't believe, it was so fast that I thought something was wrong. And I spent other 2 days checking the data, and every time I was checking, everything was right, and I just couldn't believe. And then I actually told Anton, I don't know, man, something is wrong there, because it's working. Like, he couldn't understand, but then we changed to Scala 2.10, and a few months later, they released 1.6.1 with some bug fixes and more stable. With that one, I remember we got 5% faster only by upgrading the version. And then I remember, yeah, man, I was right since the beginning by picking Spark. It was an amazing choice. Spark 2.0. From the people here that is using Spark, who is still using Spark 1.6? And who is already using 2.0 or 2 point something? How happy are you guys? A lot, right? Like, it was one of those moments that the company raised my salary. Yes, like, yeah, man, these guys, like, they are working for us. So if you guys are thinking about upgrading the version, just do it. So it's a new version. They have like breaking APIs, right? They are very seriously about the APIs. But when you're changing the major version, so something is going to be wrong, and we changed the version. We didn't have to change one line of code. It was amazing. So I was like, man, why? It's still working. And so we got it. That was the application. Right now it's running in 2.1 already with EMR. And that application is running 24/7. I don't remember the last time it crashed. So all the ads, I was actually checking a few minutes ago if all the prices were there, because imagine I'm here talking to you guys, like bragging about this application that is awesome, leveraging the work of other people that I was not even doing, and then the application is not working. But it's working, it's really awesome. The future of this application is actually going to Spark 2.2, moving to structured streaming. Because of the state before, we had to use the D stream. I wanted to go to structured streaming before, but the state was not available for structured streaming, and they're launching that in Spark 2.2 with map groups with the state. It's going to fit us very well. And now I'm going to have to thank DD. I don't know, I think you guys know this guy. He's like actually a great inspiration for me when it comes to the streaming and the work with the Spark. So the next project that we got, we actually had the production version a few months ago. This is right now a batch processing application that is our proprietary index for determining how the routes are hot for the airlines, right? And we take into consideration all the demand for the routes, like how many searches that route has for the specific airline. And we create this metric that helps us to sort and tell the airlines, hey, you guys are doing great in this one, you guys are doing kind of bad in that one. So for this case, we already started with Spark 2.1. And also, very worth mentioning, Scala 2.11. Who here develops with Scala, Spark with Scala? And with Python? Try the Scala 2.2 if you guys are using Python. I'm not saying stop programming in Python. I love Python too. Python 3 actually. But Scala 2.11 is really fast, really impressive, mainly for when it comes to collections. And like they created like some features for immutable collections that it's just amazingly fast right now. So we're using Spark SQL. So our data scientists are actually leveraging that part. Everybody's happy with that because they didn't actually need to learn Scala or anything, so they can just use the Spark SQL. And we're using data sets, which also made the things a little faster when compared to just using our previous tests with data frames. I think in Spark 2.1, everything's the same thing, but we noticed some differences. And I have to thank Michael because the work he has done with this Spark SQL is amazing. This application receives, it works with the data that we have that was collected by the other application. We have hourly batches, and we process, it's an hour batch. We process around 80 million rows per hour, but it takes about like 10 minutes to process. Just for you guys to have an idea, 80 million, if we were talking about people, is the whole population of Germany. Is there anybody from Germany here? And per day, we are around 2 billion. That would be the population of China, US, Brazil, and Germany as well. It's a lot of data for the small cluster size that we have, and we are pretty happy with the results. We're leveraging S3 for our data that goes from Redshift to be analyzed. It goes through S3, and then we output back to S3 after processing in ORRC and Parquet. and other applications that we have written in other languages of other technologies, they are leveraging that, reacting to that, and doing whatever they need. The data goes back to the data scientists, people our whole company has access to the data. Anybody in the company has access to the data. If they think, oh, what can I do with this? What are these numbers? They just go and they can answer without even talking to a developer, stopping somebody. It's very democratic. The future of this application is also going to be streaming. We want to create this index and put it in real time. We want to leverage the groups with the state, and we want to use the machine learning features from Spark using MLlib to predict what are going to be the next options, the next pricings, the next index to enable the airlines to be preemptive. You know, like they're going to do things before. They're not going to be waiting for something to be able to change their prices or change the strategies. So, summarizing, our success with the Spark is due to the fact that they have very useful features. The new features, they're cool and they are useful. It's not like some tools, oh, that feature is nice, but it's not used. No, we use it, and it's really cool. We are reliable with Spark. The clean API from streaming to batch is just amazing. Performance, I don't know if you guys saw the keynote. So when Michael said that the easiest framework to work with big data right now is also the fastest. And it's very simple, the management. And that's why we chose Spark. Thank you, guys. If you have any questions, the time is up already. But if you guys have any questions, we're going to be around. Any questions related to streaming or Spark or airlines or Everymundo or Miami, you just reach us out and we're going to be glad to answer you. Thank you.